Hey guys, so we're going to move on to our second lesson of chapter 9. So before going through this, you need to watch the 9-1 notes if you haven't already. This is an extension of those notes. So we're still working with solve by square root and solve by factoring. We're just going to kind of show you how some problems can actually be used with either method. I want to make sure that you understand when you can use which one. So in the notes yesterday, we talked about when you can use square root method and then when you can use solve by factoring. And really, factoring is when you can't use square root method. So in order to use the square root method, you cannot have a b term. So in quadratic equation of ax squared plus bx plus c, you're not going to have the b term. So an example of this would be like 4x squared equals 16. I don't have a just x term. Or you guys saw an example in the 9-1 notes of like x plus 1 squared equals 25. If we want to do this does not have an x term because this is all on the inside of the squared. So that would be considered your a. There's not a something times x on the outside. So if you can't use the square root method, that means there is that b term. And you saw lots of examples of it. So an example could be, let's say x squared plus 5x plus 4 equals 0. You have this b term. So make sure that you are understanding square root method does not have that middle term. Okay, factoring method does. And you can still factor some stuff that you could use a square root method for, but you can't always go in both directions. And that's the point of today's lesson, is looking at that. So the problems that we're going to look at for these first 4 examples, they can actually work both directions. And throughout this, you'll see, well, I would have started with a certain method and then maybe switched to another one halfway through, and it really just kind of depends on how you see it. So for number 1, 3x squared minus 25 equals 0. If I'm going to solve that by the square root method, I have to get the x squared alone. So the first thing I'm going to do is add 25 to both sides. 30. Now I'm going to divide by 36. Again, I have to get the x squared alone. And that is a x squared equals, and then some of us are going to look at that 25 over 36 and go, oh, that's really gross. That's sounding like crazy decimal. Don't change it to a decimal. You'll see why here in just a minute. Leave it 25 over 36. Because now x squared is alone and the square root both sides. So I get x equals plus or minus. Remember, every time you have to draw in that square root sign, you have to have the positive and the negative square root accounted for. So the square root of 25/36, you just take the square root of the numerator. The square root of 25 is 5 over the square root of 36 is 6. And that does not reduce, so final answer is plus or minus 5, 6. So we have our 2 answers there. So now let's look about, well, what if I wanted to factor that? Some of you may have recognized that, hey, 36x squared minus 25 is a difference of 2 squares. Difference because they are subtracting. 2 squares, 36x squared and 25 are both perfect squares. So if you recognize that, you can set it up to factor. And you say, well, difference of 2 squares, one is plus and one is minus. And the square root of 36x squared is 6x. So these both have 6x. And the square root of 25 is 5. So there would be the factored form. And then from yesterday, this would be solved by using the zero product property. It's equal to 0. So you would say 6x plus 5 is equal to 0. And 6x minus 5 has to be equal to 0. And solve each one. So subtract the 5, divide by 6, and I get negative 5, 6. And I got to solve the other side. I would add 5. Now divide by 6, and I get positive 5, 6. So notice I get the same answer either way. Both of these are the same. They're just displayed in two different forms, and they use two different methods. They're both right. So it doesn't matter which one you would have chosen, as long as you go through it correctly. So number 2 is kind of the same idea. Now, square root method to me seems faster for this one because the x squared is already almost alone. So if I divide both sides by 49, I get 81 over 49. And again, you know, that fraction looks kind of big and scary, but I recognize, hey, those are both perfect squares. I square root both sides, and I get x equals positive and negative. The square root of 81 is 9 over the square root of 49 is 7. And I'm done. Positive and negative 9/7. So those are my two answers there. Factoring, I could have done factoring for this one. We just have to remember from our notes on 9/1 that, hey, if I'm going to solve by factoring, I have to get the equation equal to 0. And that's every single time. So if I choose this method, I've got to subtract 81 from both sides before I can factor. And then I go, ooh, it's a difference of 2 squares. So 7x plus 9 and 7x minus 9 is equal to 0. And set each of these equal to 0. So in this method, you can see that it's definitely more work. It's not an atrocious amount, but it does take more. So it's all about recognizing which method is fastest. Now, in the end, you know, as long as we get a right answer, we're good. But I also know that all of us want to take the shortest or fastest route possible. And so in this case, the square root method definitely would have been faster than the factoring method. But wait, I just want to make sure that you see it can be solved both ways. Okay, so now let's look at 3 and 4. So what's different with these is, hey, they have this b term. Oops, turn my marker back on, sorry guys. And as soon as we see that, we go, oh, I can't do the square root method, I have to factor. So let's start with the factoring method on this one. So if I look at it and go, well, that is an x and an x, because it's a 1x squared. What two numbers multiply to be 4 and add to be negative 4? Well, that's negative 2 and negative 2. And say, hey, those match. So all I have to show is x minus 2 equals 0 and x equal 2. So I only get one solution there. So now some of you guys are going, well, where does the square root method come into play here? And it is due to the fact that we have the same binomial twice. If you really wanted to, again, it's slightly more work. But you could rewrite it as quantity squared. Then, okay, there's nothing outside these parentheses. So let's get rid of the exponent. Square root both sides. All the square rooting does is gets rid of the exponent. So I'm going to have x minus 2 is equal to, well, the square root of 0 is 0. And remember, we don't bother writing positive 0 and negative 0 because both of those are just 0. So we would add 2 to both sides, and we get x equals 2. Same answer, it's a different method. All right, so I want you to pause the video, and I want you to try number 4 on your own. Think about, well, what method would we begin with and why? And then find your answer. And then see if you can relate it to the other method as well. Okay, so for factoring, this factors into x plus 5 times x plus 5. Factoring method, since they match, we only have to show it once, and we get x is equal to negative 5. So the square root method on this one, if you wanted to translate it into that, x plus 5 squared is equal to 0. Square root both sides. All that does is get rid of the exponent, subtract 5, and we get the same answer. Okay, so really, every problem is a little bit different, and you're going to have to look at it and interpret what method should I use, and then from there, go and say, do I stick with that method, or do I want to change to another one halfway through it? Okay? Oops. So if I scroll to this next part, this is based more off of yesterday's notes than being able to go back and forth between the two methods. And it's, well, what if I'm going to solve by factoring and there's a GCF? So it's a big thing in factoring that we always pull a GCF first if there is one. And in the 9-1 notes, nothing had a GCF, right? We were just starting them off. How do you solve by factoring? So we're going to go through this today. On 5, 2x squared plus 10x plus 8. So that has a GCF of 2. So first thing you're going to do is you're going to factor out the 2. So factoring is dividing. So if I divide all of these by 2, I get x squared plus 5x plus 4 is equal to 0. Now I'm not done factoring, right? Everything on the inside is parentheses. That can still be factored. The GCF is just going to hang out with us. So if I factor this, I know they have an x and an x. What two numbers multiply to be 4 and add to be 5? Well, that is positive 4 and positive 1. Now that it's factored, we would do the zero product property and say, well, if A times B is 0, then one of those has to be equaling to 0. But then there's this question of like, well, what about the GCF guy out here? Like, is that a C? And what you have to ask yourself is, does that GCF have a variable? And in this case, no. If your GCF doesn't have a variable, it's kind of extra information that you don't need to be able to solve. So we actually forget about our GCF. We kind of leave him out in the cold, and we just go through and take the pieces with our variables and set those equal to 0 and solve. So we get negative 4 and negative 1. Now, technically, when solving, if you don't pull the GCF, you still end up with the same answer if you still factored it correctly without the GCF. But again, factoring out a GCF at the beginning makes the factoring after that easier because I didn't have to go through a whole guess and check. I had a leading coefficient of a 1x squared, and I could just pop my numbers in using mental math. So that's why pulling the GCF is still important and helpful. So if you can't on 6, I want you to pause your video and I want you to try that on your own. And then start the video after you've attempted on your own, and let's see how you did. So if you watch the 9-1 videos, you know that before I can even start to factor this, I have to get it equal to 0. So subtract 80 from both sides. That's a 0, 80. All right, now I notice there's a GCF of 4. I'm going to bring that out front. And again, what's super helpful about that is I now have a leading coefficient of 1. The 4 is still going to tag along, but this makes factoring, oops, it's an A, not an X. So it makes factoring easier. Which numbers multiply to be negative 20 and add to be negative 1? That would be a negative 5 and a positive 4. So when I'm using the zero product property, again, this GCF does not have a variable. So it's not going to help me solve. What it helped me do was factor faster. So I'm only going to set the pieces that have variables equal to 0. So A is 5 and negative 4. And then you're done. Okay, on these last two, these are the same idea, but they're slightly different. So at first, we might look at these and go, ooh, I can use the square root method because there's only 2 terms. But we'd go, oops, wait a minute. I have that B term. I have that X term. So I can't use the square root method. I say, well, I have to factor it then. Well, how do I factor an x squared plus 4x? I can recognize, hey, they have a GCF of 1x. If I factor that out, then I have x plus 4. And now it's factored, and I'm still going through and having to say, well, a times b is equal to 0. And I go, well, I only have 1 set of parentheses. But look at this, the GCF this time is a variable. It has a variable. So because it has a variable, it is included in the zero product property. We take a times b equaling 0. So for this one, the GCF was just x. So I have to set x equal to 0. And as far as solving goes, that piece is done. Then I have to set the x plus 4 equal to 0. Solve that, and there's my second answer. So it's actually pretty nice if your GCF is a variable, because setting it equal to 0 is usually super easy. 8, same idea, right? What's the GCF number 8? It is a 3x. And if I factor out the 3x, that leaves me with a 1x minus 9. And again, now we're factored. Because this has a variable, I have to set it equal to 0. So 3x is equal to 0. And then the x minus 9 is equal to 0. Solve each of these. Divide both sides by 3. I still get x is 0. And on this side, add 9. I get x equals 9. Okay, so hopefully this helps you to complete the homework, right? Really strategize and look to see, can I use square root method or do I have to factor? Is there a GCF? It's very important to pull those if they are there. And remember, if you have any questions, make sure you conference your teacher to be able to ask.